Okay, you've inspected all the wiring, it's all good, all the connectors are connected fully. Now what you need to do is test the throttle. I will explain the whole throttle with this scooter. Basically, this wire is coming from the display, and it's going directly into the rear controller. The green wire is the throttle signal, and you should be getting, if the display is lit up and the battery is connected, obviously you should be getting something in between 0.8 up to 1.2 at rest, and at full throttle you should be getting anything from 3 volts up to 3.8. Now, if you're getting, like, if you're measuring here from here and like this, and you're getting the right voltage, probably means that there's something else going on. But if, let's say, you only have one motor that is running, and it's the rear, and when you select dual, the front does not engage, it's possible that it's just the connection between the throttle signal and the front motor. You know, the way the dual and single switch works, it just basically it connects the throttle signal up to the front motor. So as you can see here, the throttle signal is going to a connector here, which goes up to the handlebars and goes into the dual single switch. So basically when you hit the dual switch, it shorts out these two wires, and the signal that is coming from this the display goes to the front controller. If you disconnect this connector here, the front motor will never work. So make sure like the pins are all straight. So once connected, what you do is you leave the black in here, and you take your positive and you measure on each side. You should be getting the same voltage that you measured off this one. All sensor testing. First, connect the battery to both controller, locate the two hall sensor connector, power the display, take your multimeter and measure the voltage between the ground and the positive. You should be getting 5 volt DC on each connector. Once you get that 5 volt DC, leave the black probe on the black wire and take the red positive and move it to the blue wire. Sorry, easier to hold just one connector, like this. Hold that, and with your other end, rotate the wheel. So spin it really slowly and watch your multimeter. It should be shifting from 0 to 5 volt or close to. So if you see a shift in the voltage with each magnet pass, that means that the controller is getting the signal. If you do have that signal, move to the next one, to the green wire. Repeat the process, turn the wheel. You should be getting a shift from 0 to 5 volt, and at last to the yellow one. If you get a voltage that is stuck at 5 volt or at 0 volt, make sure the wire is connected correctly. If you're unsure and it looks like it's all good, maybe you should remove the insulation on the wire, like let's say the yellow one, and measure from it like this. If you're still not getting any shift, then it's probable that one of the motor has a Hall sensor issue and needs to be opened up and replaced. It's not a super easy job to do, but it's totally doable. There are many guides online on this. I will show you some links in the troubleshooting guide. So repeat the same process for the other Hall sensor connector. And if you get shift on all the phase, it means that your Hall sensor are good. So The problem lies somewhere else. Wiring. Okay, so you already know what the green wire does. It's the throttle signal, goes to the front switch, and the front switch activates the front controller. Now, the black wire is the ground. The white wire is the speed signal, just basically tells the display that the motors are running, so the display won't shut down after a few seconds. And also it will help display the speed you're running at. Red wire is the battery positive. Orange wire is the ignition. So as soon as the display is powered on, this wire becomes live with full voltage. It powers the rear controller. From the rear controller, you got another orange wire. It goes to the front, does the same job. Coming from the rear controller, you have a red and black connector connected to nothing. It does nothing, but just be careful. It's full voltage, so you can use some electrical tape over it to cover it, just in case, like, I don't know, something shorts out the two connectors here. White and black, echo and turbo switch. Goes to the front switch. This one is really hard to miss. If you want to know, the wire coming from the color code is red and yellow. So red and yellow goes to black and white. Goes to both controllers. Yellow and black, same thing. It's coming from the front. Those are the brake levers. Brake levers wiring are red and black. Red and black goes to black and yellow. They're not, there's no polarity, so it doesn't matter. It's just basically to shut down both controllers if you brake. All sensor, phase wire. All we have left are two sets of wires, both the same color, yellow, black, and red. Yellow, black, and red. One is the light switch and horn switch. The other one is the actual light and horn combo in the front. No connection, no connectors, no crimps. They're soldered directly and they are connected directly to the battery. Just make sure they're clean. You can tape over if you want, but they're live 60 volt DC. So hope you understood how the wiring works and how the scooter works. So thanks again. All right, we're done. All we need to do now is put back the battery and put back the scooter together. First thing is controllers. You add some thermal paste in between the controllers and the deck. You need thermal paste again. So if you have to clean it off and you don't have any left, go buy some thermal paste. It's really important because the controllers, they generate a lot of heat, and that heat needs to be transferred to the deck. So get some thermal paste, spread it at the bottom, slide the controllers in. Once the controllers are fully inserted, use some RTV or any kind of semi-flexible adhesive. Put some at the top so the controller won't slide off. Wait till some are take an hour or two, some take 24 hours to cure. So wait before you move anything. Make sure the controllers are held in place. So next thing, wiring. Put the small wires at the bottom and leave the phase wire on top. The reason is phase wires, they get hot, they generate a lot of heat, so heat rises. So it's better to have the wiring, the small wires at the bottom, and make sure if you can put some fusion tape all over it so they won't touch any of the small connectors or any small wires. Do the same for the rear. Once it's all done, well, you could use some zip ties if you want to hold all the wiring in place. It's optional. Now the battery. Make sure the light wires and the brake lines are on each side. You could use some tape to make sure like you don't crush any of the small wires. The battery was held with double-sided tape. You could continue with double-sided tape, or you could actually just use some foam. So what I do is I cut small pieces of thick foam like this, put some at the bottom, slide the battery in, and wedge small pieces of foam on each side so the battery will not be able to move side to side. But you will need to make like a bumper so the battery won't be able to crush the wiring. So you could fold foam like this and make a bumper for the battery so it won't crush the wiring. Once everything is in place, you will probably need to put some foam on top of the battery so the battery won't move up and down. So once it's all done, put the cover on and go have fun riding.